Yep, we're running. Right, today is travel. This is quite an interesting one, which we're going to want to know about here, because although I think any space agencies that ever listen to this, if they ever do, are not going to want to bother travelling after this video. Maybe in our solar system, but I think anything further beyond, you won't get any results in their lifetime or our lifetime. So there's no point. So travel. How do they get here, and how will we get to other places? There is only really one way, and that's to accelerate as fast as you can towards wherever you want to go, or where it's going to be. You've got to calculate where it's going to be when your spaceship gets there. So if it's over here and it's moving in that direction, you've got to go over there so that you both meet. Otherwise it's a bit like the Apollos going to the moon. You know, they'd go that way and the moon would go round a few times, then they'd meet it and catch up with its gravity. That's what you have to do. Travelling, now, most ships that come here, except very early on, we don't know why this is, I didn't ask the question, very early on the spaceships were different, the motherships were a different shape, or were completely self-contained. You couldn't call them a mothership because they didn't have any satellites. But the one that, the probe that I came across, basically came from a mothership and couldn't survive without it. So yeah, so the mothership was long, as we've said in the mothership video. So there it is, and basically that came here, knowing from previous information, although it had never been here before, because all the motherships exploring all transmit to each other, it had information about the Earth already. And obviously there's telescopes and things flying about too, so like us, we can see quite a way with our telescopes just by the light coming towards in our direction. So yes, we can sort of guess that there are planets going round other suns elsewhere, just by them passing in front of the light source makes it dim for a second, so we know there's something going round. So yeah, basically, so they would have set off from their last destination aiming at us, and they would accelerate with all the fuel they had on board, and then as soon as the fuel ran out and then there was no power, they would shut down. No point leaving a bit of power, because even, doesn't matter, you know, batteries or capacitors, they use I'll tell you what the storage source is. It's a 1 atom thick layer of carbon layer on 2 or 3 atoms thick of foil, and then that's wound into what we now call a capacitor. So, but they're giant, you know, and that everything is 2 atoms and 1 atom, because it's all built on a 3D printer. Basically, you can be 1 atom or 2 atoms thick, because these 3D printers that they've got, even on the mothership's got one, they basically can place 1 atom at a time, if necessary, to get very, very fine detail, especially with electronics. So the capacitors, a couple of atoms thick of foil, as big as you want the capacitor and as long, which is generally hundreds of yards, 1 atom of carbon, and then roll it up, and you've got a a very, very high quality capacitor. We haven't got to that stage yet, I don't think here, but if we did, you wouldn't have heavy lead acid batteries everywhere. You'd have just the one capacitor, and various other things are done to the capacitors, like dipped at into liquid nitrogen, etc., to try and get the superconducting element of it. But I didn't ask that, I'm guessing that, by the way. But the capacitors, you know, I said, what power source are you using? And they didn't say what it was, they just put a diagram on the screen of and it taken undone in bits from being a cylinder to basically being unrolled in front of me on the screen and showing one layer of carbon and one layer of metal. Well, it was a black substance and a silver substance, so I'm just suggesting it was, pretty sure it's carbon anyway. So next thing, once that's run out, everything shuts down and the thing is just a lump in space, basically. When it gets near the next sun, it will come back to life, charge up everything, come back to life. Don't know how far out that will be, but believe me, I mean the solar system on these spacecraft is way ahead of anything we've got at the moment, all because it's built one atom at a time. So that gets to within range of our sun, all comes back to life, comes into our solar system, drops its probes to each planet. It might, I couldn't really get a handle on whether it drops them at each planet or whether it stops somewhere. I did get one system that comes in and stays behind, especially if there's an automatic system or for destruction, because, you know, cut a long story short, some solar systems might have 2 or 3 planets that are all warring with each other or trying to get resources or whatever. So some might have on the outer planets of the solar system a very high quality destruction system for anything trying to come in to attack. Occasionally these systems are still on the planets after the planet the producing planet has died, or the one it's trying to protect, but it's still out there protecting, and the chap with the who produced it is gone a long time ago. So yeah, so you have to watch that. That comes in. Some of them hide behind the sun, so they're eclipsed. There's the sun in the middle. Here's the target planet. So they're actually eclipsed the whole time. So this one, because they're blinded by the light, can't see the mothership. Although we have spotted stuff going round the sun, little dots, and that are supposed to be, have been calculated to be miles wide. So that could be this could be 2 miles long, you see. So, or it could come into the planet, pick up the probes and then go again. Or all the probes could come to a central planet, then it comes into the atmosphere, grabs them and then is gone. Some people have seen cigar-shaped UFOs stay in our atmosphere for a while. Now that's because they're obviously planning their way out. Now, if you imagine there's the sun, here's all the planets going round. It's sitting there calculating on the Earth there, and it has to. It's good to use the sun as a slingshot because of the heavy gravitational field. But the more gravitational fields you can get on your way out to slingshot round, the faster your outgoing speed will be. And then in the back of the system, as we've seen before, if I make that bit bigger, there's all the transmitters. Now these are tubes with coils that accelerate particles, which can be used for a number of different things. They can be used for transmission of information. There's many, many more than that, and some of these are hundreds of yards long. So, out the back ones, you can change the particle that goes in at this end to something heavy. So you've got heavy particles shifting out the back, almost like a rocket motor, but more like our ion drive. Now I don't know whether ions are heavy or not, I don't know, I don't know anything about them really. But I've heard there's an ion drive that throws particles out the back of a spaceship and moves it in the other direction. So that would use all those heavy particles. As soon as the fuel's run out, that stops and the computer shuts down. And basically, if there's no, I don't think particles is a problem. I think it's the electricity to drive the coils that will be the problem. So as soon as that electricity runs out, the whole thing shuts down, and a few course corrections by using these. Just putting heavy particles in the end of the tubes and firing them out. So you can do a course correction a bit, and then as soon as you're definitely in the right direction, another quick burst here, make sure you're going in the straight speed, and you're away. And then that won't wake up again. That could be dormant for 800,000 years, and it won't wake up again. Which is why, if we're going to send out exploring ships, we've got to know that the communication protocol between all these ships first, and our Earth isn't going to get that or be in contact or get any information. They're not going to contact us until we got our rubbish here sorted out, which is coming up. That's all the next subjects. And it's to do with religion, it's to do with the country system, it's to do with money, greed, all those things. We've got to get all that out the way and sorted out, so because the country system could destroy us, religion could destroy us, and so could money. So but they want stability, knowing we're going to survive. Climate. You know, if we destroy this planet, they're not going to want to bother coming to us and telling us all those details if we destroy the planet. So that's we've got to get all that rubbish sorted out first before they'll even. They know what's going on here, there's no doubt about it. When my probe turned up, that just updated what was already on the system and then went back. And it was here, what, 10 hours-ish? So that was it. So that's travel for you. And obviously the probes, how they travel, we've already been through it in the probe section. There's 2 contra-rotating discs, and they've got round them placed. They're spun up in the mothership to some ridiculously high RPM, which we'll have to work out. I don't know what that is. I know it's fast. They're in a vacuum. They don't touch anything. They've got no bearings. It's all to do with magnetic fields. That's what they're held there. And all the fixed magnets around them, as they're one's turning that way, one's turning that way, north is lining up. There's a gap. Then south is lining up. So you get a north-south field sent out from the ship so fast that it actually stops all other effects around it. So the gravitational effect on the device, that is cancelled along with pretty much everything else. Even radiation coming from the sun doesn't know what to do around it. Anything upset by gravity, even light, because people have witnessed even on this Earth, when a ship's about to take off, or what they're viewing is about to take off, it changes colour. Now it hasn't actually changed colour, that's just the effect, the gravitational field on the ship. The ship's actually silver or I'd say titanium looking. But whether it's titanium or not, I don't know. I should think it's some incredibly complicated alloy or a ceramic of some sort, because when I knocked on the surface of the probe, it was rock hard. There was no aluminium sheet to go bang, 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 it went like concrete and was rough. Where micrometeorites have it had accelerated so fast in space that it's hit by micrometeorites basically. So, so it was that old because the whole outside surface was covered. When you go inside, it was smooth because obviously that was original. So anyway, but you know, everyone says, "Oh, I'm looking at a person who's been in a probe," but believe me, all it was a square hole. One side was a screen, which looked just like the floor and the ceiling until you sat on the block. The only feature inside the tube was a block, and so that's where if anything who comes across the probe and goes in and sits down, or leans on it, or does something, the other screen comes to life. And of course, then you've got to watch it. So it doesn't matter how ancient you are, or you know, you're going to watch that screen. And there's obviously on this earth there's been quite a few other people who have seen that stuff too. And I've got my sort of whoever the chap was in the Bible who went away for 40 days and 40 nights, came back with all these ideas. He could have been one. I don't know, there's a few others too. Anyway, back to travel. Yeah, so you're throwing out this really high speed alternating current, and that cancels everything. And obviously people driving up to the thing in a car, the engine dies because that alternating current is affecting the electrons in cables. So in a DC cable in a car, it's going round and round through the lights or whatever, back through the switch, through the battery, like that. This stops that, and then it goes backwards and forwards with the alternating current, and then stops. So all electronics, all electrons in a wire are held in this state. Not even vibrating. They might vibrate under their own accord, but not even going backwards and forwards like this. Dead stop. Then all the lights go off. Battery's no good, because that can't. It's such a high power thing that the battery can no longer drive it, no longer move the electron. So, and then when the ship's got that amount of spin to sit there, you can move the discs away from each other or closer. But also, when you tilt the disc like that, it'll act like a gyroscope. So you know that when a gyroscope's spinning, it's very difficult to turn. Big gyroscope that is. But if you're not holding it, and something else turns it, it's going to want to move, and fast. And that's what happens. It goes zoom. As soon as those discs are moved, zoom. And that's the speeds where people are witnessing on UFOs. That they say it suddenly vanished at high speed. Well, that's why, with no sound, no sound. And that's all why. Changing colour. That's because the light coming to your eye, the huge magnetic fields have changed it. Change it to a different. Now that, reverse engineering wise, that might be one way of getting to know what kind of speed and what kind of magnetic field you're going to require to change the colour. So we've got to find out from these people how close they were when their car engine stopped. If we produce that alternating magnetic field, we've got a good chance of not having to use all these massive rockets. But I'll tell you what, I like watching rockets on YouTube, and especially the Apollo series and any of the big ones, the Falcon Heavy, all that kind of thing. And you get that amazing sound and that crackling and all that smoke and all that equipment all running and pumps and the incredible engines and all that fuel and everything. And I think we're so far behind. You know, Elon Musk, you know, he's great with his innovations, and he's, you know, I admire him greatly. But when I think of what he's actually doing, and travel as well, we're getting to another travel bit. Transportation is coming up on these videos, how other people on other planets get around on their own planets, and that again is a buggy, no moving parts except the door, running in an air tube. You know, when I look at all these cars and all this sophistication, Ferraris and all the noise and all the smoke, they're great, but they can't do 2,000 miles an hour in a tube. Big aircraft trying to get off the ground with 400 people in it, you know, burning tons of fuel which never leaves our atmosphere. You know, every now and again they crash and everyone dies and it affects families right across the world, and they're only doing 600 miles an hour. We've done away with the good jets that do more than that, like Concorde, which was a complete mistake. So, you know, travel, I mean, basically the transport system, you know, when I see what they've got there, they step into it, they haven't even got time to read the paper. They're at work. Bang. You know. So we've got a long way to go, I'll tell you. And I'm hoping that some scientist will contact me and say, come and see me. And he might understand, he might be able to get out of my head what I'm trying to say, because I'm not very good at this. And, you know, talking to cameras and things and trying to remember everything. So, I mean, I've written big long notes and things and to what to say, but in the end, you know, travel. I don't know, it's best if I just sit here and chat, I think. But we've got 21 minutes, so I'll carry on for a little while, but yeah, so basically, as a summary, this thing's sitting up in the air. It's got the rotating disc system somewhere built in, which allows it to sit still. People in aircraft see them all the time. They just don't bother reporting anymore because it means they have to sit filling a form in for an hour. You know. And one of our friends saw one, and she was saying because it had no earthly features on it, features that we know, like, I mean, if somebody was standing on it with an umbrella, then we'd know how big it was. But she couldn't tell. She could tell a bit because there was clouds moving in front of it. So they could tell roughly how far away it was. There was no clouds behind it to see how far away they were. And even clouds, you can't tell how far they are away either. And the only way you can tell is if the edges are not are sort of blurred, they're close to you. If the edges are well defined, like cumulonimbus, then it's a long way away. That's the only way you can tell. Because all clouds are different sizes. But or if it travels in front of a mountain, then you can tell exactly where it is. But if the mountain wasn't there, you got no idea. Well, these are the same. When you see one, you think, is it stuck to the window, a little thing like this, or is it 10 miles away and 3 miles long? Can't tell. So, but judging by the amount of gear that was stuffed into this thing, and I was shown diagrams, I can't tell you where exactly. I can tell you what was in there, but can't remember which sections it was in. But I should imagine there's obviously some people have thought it out, because this thing's still here. It must have travelled for millions of years and it's still there. In fact, I did say how old was the probe that I was sitting in, and because it had no relation to our time or our it couldn't tell me, you know. But like I say, I was asking the questions and it didn't ask me anything. The only thing it asked me was at the end was if I wanted a quick boost of information, because it had to go. Its exit window was coming. So that's another story. I've already said that in the probes one anyway. So yeah, slingshot out of the planet. We're using that now with our satellite, so we know about that. Obviously the bigger gravitational planets you can get, the better. And the more speed you get. And the closer you get to the planet, the faster you get slung off. Gravitational slingshot. And then you've got to use your fuel. Trouble is, you see, using particles like this takes many years to accelerate to the speed you want to. So I would suggest they slingshot first and then start using the fuel on the way out. And do your course corrections and everything, and then shut the system off and hope for the best. Now if you do miss the next sun, or if it gets destroyed before you get there, or blows up or something, supernova, then it will come back to life when it sees another light source. And believe me, there's millions out there. Just a quick, while we've got 4 more minutes, if you were to go and borrow a night vision night sight, an army one's better than a civilian one, wait for a clear night when the stars out there, go outside, have a look up, you can see the plough and you can see all this star formations. Now switch that thing on and have another look. It's like milk. This even night vision devices on this earth can see 99% more stars than our naked eye. So that will give you some idea, and they're all suns, all planets, you know, a few planets here, but they're all suns, and who knows what they've got going around them. Okay, thank you very much, and the next, I'm not sure what the next video is, but there's a good lot of videos. I think it came to 25 or 26 in the end, covering every subject. I'm better off talking about one subject at a time if I don't do any notes. And I've tried notes and everything, and I just keep forgetting stuff. It's best if I start talking and then I can remember. What do you call it? Trigger memory. One thing triggers another. It's like telling jokes, you know, with a group of people. People remember. Right, 27 minutes. Thank you very much, and see you in the next video.